Today we're taking a brief overview look at our new digital cone software. Digital cone software, which is currently a beta version, is developed by Vertek to work with either its HT series data acquisition units or with its HT series data acquisition units. We've tried to combine the better feature of each software into a uniform display that we hope everybody finds more user-friendly. In System Setup Troubleshoot, we can select which series we're going to operate with. We've got the VTK series equipment with me today. Before we hook the data acquisition and the cone up, we can preset what we're planning to use. Say you want to get the computer set up before you go out in the field. You can quickly go in and say, yes, I'm going to be looking at a standard cone today. That's going to be a module 5. And I'm going to look at the tip, sleeve, and pore pressure. And I'm going to display those data. And I want to see them in tons per square foot. Tons per square foot and PSI. There are many options in what you can display these functions as, and you certainly can choose whatever you like from the drop-down menus. We'll take a baseline on the important channels, and we're going to make sure we record all the channels. We like to do that as engineers sometimes want to go in and see maybe more data than the operator does need to see while he's doing the push, and that's just a good thing to have in the raw data file. Depth units can be displayed in either metric or in feet. So you can select meters or feet here. Push speed will always be displayed in centimeters per second, so it's easier to find to match up to ASTM standards. With the Vertek series, we're using a potentiometer, so encoder direction and resolution have no real bearing. We don't even really need to keep track of the serial number, as we're going to calibrate the stroke when we hook the equipment up, and we'll do that right here. Time-based or depth-based, if you are doing ASTM standard rate pushes, this doesn't really matter. If you're doing something slower, perhaps you have a video module where you want to go really slow and watch a granularity, you would want to go to time-based so that you would snag more information or a finer group of information, because you do it every so many milliseconds rather than every so many centimeters. Down to bottom, there are some basic setups for what we're going to do and how you want the thing to look. You can have a drop-down menu on what you want to put on the screen headers, and there's 2 screen headers. You can grab test ID and file name, which I'm grabbing today, or the client and the location, whatever you plan on keeping track of them as. Serial port that we're attached to on this computer is serial port COM4. That's for the data acquisition system. If we had a GPS or other devices attached, we would have different ports for those. So we're going to save this, and then we're going to start the test. When you hit start, you've got your items connected, and it's going to go look for the different modules that we saw in those menus, and it's found a data pack on module 3, and it's found a cone on module 5, which is just what we anticipated finding. It's not finding an FFD, a video camera, or a counter, or a special multi-sleeve cone. It's not finding none of those things. So now it's going to tell us what it found. It found a data pack 2010 and a cone serial number 2659.103. So we say OK, and then we'll pop up to our screen. Now we have decided that we want to display tip, sleeve, and pore pressure. If you have different items you want to set up for a push, you can change these right here and then exit, and it will save those. So if you're doing a push where you've got different items you want to display right along, that's all can easily be done. As you see, there are other options here. I really don't want to display 4 channels today, so I'm going to just change my number of graphs to 3. So I only display 3 graphs, so I'm not confused by any extra lines. You can see across the bottom, all of the stuff that we wanted to display is available here as a number. These are all the items that we left checked at the beginning. And you can see they've got some readings and whatnot. Now we're going to check our module offset. This is only used if you're going to put another module on top of the CPT cone, and that's so that the second module up knows where its data should start being measured from. In this case, I'm saying it's 43 meters back from the centroid of the tip. So now we're going to take a baseline. Now the cone was leaning off a little bit, and I've just suspended it perpendicular, and I'm going to take a baseline, and you can see the inclinometer popped into position. And when the inclinometer is in position, it's nice and green. And a little clue for the operator: if you start getting offline, it will pop over to yellow, say, hey, this is getting to be a little bit of an issue. And when you go offline quite a bit, it says, whoa. At this point, if you had your quit selected, you would be getting a quit message. We didn't have quit selected today, but we certainly could have. In system setup, now we'll take a look at our depth potentiometer. Now I set up my depth potentiometer here today with the string pot at the low side of my push, so that when I start a push at 0 meters, I have the string extended upwards. So that when I extend that string upwards, it comes up to, I'm now pulling the string out. I pull it out 1 meter approximately, and you can see it's just about the measurement that I had originally told it. So we would then set the depth, and then we'd let the string pot run back in to fully retracted, and then we would set to 1 meter. And that's as simple as that. We do recommend checking that on a daily basis. Things do change, components do develop issues. It's just a wise thing to check your parameters on a regular basis. Now we'd already set up our cone 3 or module 5 previously, so we don't really need to go into that. So we're going to save that system setup. Now we've got to take a baseline before and then name a test setup. We have to name our test in order to be able to hit start. It wouldn't let us hit start if we didn't do this. So now we're going to put a test ID in. And again, that is a number that I like to put up on the screen, but it may not be. As you can see, we'll call it 129. There's a lot of different options of test information that you can have: project, site, location, client, client representative, comments, weather, rain. Today it's nice and dry. And it's cold up here in New England today. It automatically puts in the date and the time. Start depth is if you want to do an elevation based push. If you knew the elevation and you want to put that in and then push minus, you could do that by putting in a elevation here. If you had a GPS unit hooked up, you could acquire GPS data and it would automatically pop in. You have your choice on where to store the push data. Here I'm going right into the C drive right on the root. And I call it a test ID of 129, so I'm going to name the file 129. And the file name is what you will find when you go looking for the raw data on your computer. So that's a good number to remember, which is why I like to put it on the screen. You can see here's the test ID and the file name. So now I've got the cone sitting on the ground, and we've taken a baseline with it elevated, so we'll lift it back up. Now we'll push start. Whoop, we don't want to put, now we want to unclamp because I've got a manual clamp selection going here. Let's move my screen just a little bit. So we unclamp so I can pull the string out. Now I'm setting the cone back on the tip, and I'll hit clamp. And I'm going to go in. Now my hand is not steady enough to maintain the 2 centimeters a second very well. You can see when it's at 2 centimeters a second, it's green. And when I'm bouncing around up and down because my hand is jerking a little bit on the string. You're getting different readings. And see, I just put a little tip pressure on, and if first scale comes up as 0 to 1, obviously that's not going to cover any amount of normal pushing. So we're going to hit the unclamp right here and let the string go. And we're going to change our display here so that the tip goes from 0 to 20. We'll say OK. Look like that. Look at that. Maybe we want to go minus 1 to 20. There. Now we can see what's going on. We actually have a little bit of a minus going because of the calibration. This is a lab cone that is really a little bit out of whack, so we'll just use this for demonstration. You can see when I'm putting pressure on a tip, I'm getting a little bit of pore pressure, but very little because that's also 0 to 1. So that's very minor. Let's get that. Okay. So now we're going to hit the clamp again, and we're going to pull the string pot out. And we'll hit the clamp again. And we'll let the string pot go in. You can see the data goes merrily on. Since I'm in a manual situation, should you forget and go back up, you see that data's going back up. So it's keeping track of where it is because it says I'm clamped. So if I'm moving, I must be gathering data. If you had an automatic switch, if you had switches in position to know when you should be gathering data, or pressure switches, then you would auto clamp as you were in and out of position rather than having to manually clamp. People using on drill rigs and whatnot just go with the manual clamp usually. So that's enough of a sample push to just sitting at a desk. We'll hit stop now. It says, are you sure? And I say, yes, I'm sure. And now we're going to take a quick look at the data we just gathered from that. So we open up the cone plot program. Let's look at depth plots, and that was 129, if I'm not mistaken. And it was tip, sleeve, and pore pressure. And we hit plot, and there's just what we had on the graph. Now this cone plot settings came up in PSI, PSI, and PSI because that's what I had selected in the cone plot. You can change all those settings up here. You can even plot out stratigraphy if you'd like. That pops up here as well. One more quick look. We'll take a quick look at the raw data file since we did mention that earlier. And we'll just close cone plot entirely. And we'll go to my computer. And we'll go to where I had stored the data, 129. And I'm going to open it with Notepad, which I should have selected as the default. Notepad. And I should always use the selected program for this kind of file. So yes. And here's the raw data. See, all our header information is stored up and above. And we have this area here is all the calibration data and baseline data that was stored. And then from the space down is the data gathered at each data point during that push. As you can see, it's a lot of data in a short time, which is why we like to use the cone plot. You can take this data and go right into your own spreadsheets or other software if you like. It certainly is a possibility. And that's a brief overview of our new cone plot for Vertek series and HT series cones.